Hello and welcome. Double trouble equations this time. They have this similar kind of theme. They're not that difficult, but they illustrate a particular manipulation that I think overall it will help you with manipulating your general algebra. It will help you with the general study of the subject, really. So we're going to look at them in a little bit more detail. They'll be suitable even for top students at GCSE level, although this is more sort of like A-level manipulation. So let's look at the first equation. Let me write on the top, x minus 4 all cubed plus 16 lots of 4 minus x all cubed is equal to 120. What's the first thing that comes to our head when we're looking at something like this? Probably expanding these brackets and solving from there. Is that easy to solve? Well, they're going to be cubics. They're very easy binomials. Do the cubic terms cancel? The answer is no. And why not? Is because, of course, when we're looking at this is going to create an x cubed. When we look at this particular one, this x cubed bit will have a 16 in there, and therefore we're going to have a fully blown cubic. And this 120 constant term that we got in there, there's going to be more constant terms in there, but unless it's something fairly small, we'll be looking for possibly a lot of factors, and I don't know if this question, it'll be easy to solve from there. Okay, it might be difficult to actually look for a factor. So what is there for us to see? Let's have a look at what we can actually see in there. I'm going to start, since both of them, there's an x minus 4 and x minus 4 in there. Let's look at the x minus 4, but that's not special. So let's look at the x minus 4 and then compare it with, of course, let's look at x minus 4 all squared and compare it with 4 minus x all squared. I can expand both of these very, very easily, but I'm going to do it in a very bizarre way. I'm going to factorize inside a big square bracket a minus 1, and I'm going to swap this into an x minus 4. This is, of course, exactly the same. There's your minus x, there's your plus 4. And then I'm going to split it into a minus 1 and an x minus 4, all squared, all squared. And if we see what happens in there, the minus 1 all squared, of course, will go to a plus, and this will, of course, become x minus 4 all squared. So this is what happens with this bracket if it's squared. Of course, we could have checked it very, very easily by just squaring it. But let's look at the cubing now. 4 minus x all cubed, I'm going to do exactly the same thing, minus 1, and write it backwards. But now it's going to be cubed. So that's again your 4 minus x. If we now split into two separate quantities, we're going to get, of course, this. But this time, the minus 1, when it gets cubed, of course, is going to give us, a minus 1 at the front. That's from this term here. And an x minus 4 all cubed. So if we compare the 4 minus x all cubed, it will become a minus if I swap it cubed. And let's do a couple more. I'm going to do a lot very fast this time. If I go to the 4, I'm doing exactly the same things. And perhaps you'll get the idea of what I'm actually trying to get you to see here. Minus 1 all to the power of 4 is, of course, positive. So I'm not going to write anything for it. And that, of course, will now give us exactly the same. If I swap them and the power is even, it makes no difference. However, of course, if we have it to the power of 5, for example, we expect, of course, to generate a minus. And it's obvious why we're going to generate a minus. We can actually see it now through these examples, what is going on. There's my minus 1 to the power of 5, the x minus 4 to the power of 5, and this will return me negative. And I'm going to get the negative of what I started without expanding at all. If I'm raising a binomial, something, it doesn't have to be x, it could be anything, two quantities to some power. If I swap them, it makes no difference if the power is even, but of course it will create the negative of what I started with if the power is odd. And that's quite interesting when I'm looking at my expression, or not my expression, my equation rather, that I've got up there. If we look at the equation, it contains the terms x minus 4 and 4 minus x. I can swap in fact either, but of course let's swap the ugly one, the one that's 4 minus x. The question is, if I swap it, is it exactly the same or does it generate a minus? The power is cubed, which of course is an odd power. Therefore, if I now swap it, this will now generate, this pen is now dying, swap it, x minus 4 all cubed. Because it's odd, it will create a minus. I'm going to put that at the front. 16 is equal to 120. Is that easy? Of course it's easy, because now I've got 1 times this bracket cubed minus 16 lots of this bracket cubed. I've got altogether negative 15. X minus 4 all cubed is equal to 120. We can divide both sides by negative 15. So x minus 4 all cubed is negative first of all. 120 divided by 15. 8 15ths is 120. You can use your calculator, I guess, perhaps. And then the cube root is unique. So if I have to cube root this can only be the negative 2. There's no plus or minus for cube roots. And therefore, that will be the x minus 4 is equal to minus 2. And in fact, there's only one real solution for this problem. And the answer is, of course, x is equal to 2. Okay. Halfway into the question. We got another equation. It's of the same style. Let's have a look at it. It should be a lot easier now, although it's a little bit more complicated as a question. Having seen now how we do the first one, I think it's a little bit easier perhaps to think what to do for the second. So let's write it first of all again. 8 minus 2x to the power of 7. I don't like this 73 at all. Okay. Here we had the x minus 4 and the 4 minus x, and we swapped it. We don't quite have the same things in there, or do we? Let's do a little bit of a side working in there. Where can I put it? I can put it here and I'm going to rub it off perhaps. If we look at the 8 minus 2x, which is to the power of 7, I'm going to stay still within this bracket and say, okay, that's still to the power of 7. Can I perhaps factorize inside the square bracket something? And yes, of course I can. I can factorize a 2. So that will become 2 bracket 4 minus x. That's good. Okay. I would like to have x minus 4 really. So perhaps it's a better idea to factorize a minus 2, and I can write inside the bracket instead an x minus 4. Let's check it. It does indeed gives us the same, and it should. Of course, a minus 2x there and a positive 8, which we've got in there. And maybe now we can actually do it from first principles, like I was showing you up there a few minutes ago. So I can actually write minus 2, that's the minus 2 in there, all to the power of 7 times x minus 4 to the power of 7. So this is going to be my result I'm going to write up there. So let's prepare the equation. 55 x minus 4 to the power of 7. What is this? First of all, it's definitely a negative quantity. Okay, because minus to a power which is odd, it will return me, of course, a negative number. What is 2 to the 7? It's 128, but if you cannot readily see it, just 1, 2, 3, 4, 5, 6, 7, 2, 4, 8, 16, 32, 64, 128. So that is that. And of course, I got now an x minus 4 to the power of 7 is equal to 73. Is that hard? Well, it depends on what this gives me, because I've got 55 lots of this bracket to the 7 minus 128 lots of the same bracket to the 7. So it's 128, take away 55. Should be 73, I hope. Otherwise, we're going to be in trouble. They're going to have ugly numbers. 5, 3, it is 73. But it's negative 73, of course. Minus 73, x minus 4 to the power of 7 is, of course, 73. Divide both sides by negative 73. X minus 4 to the power of 7 is equal to minus 1. And of course, what is the seventh root of -1? The answer, of course, again, because I'm not power, the answer is unique. And I hope we can actually see that this is in fact -1. -1 times -1 times -1 7 times. Of course, it'll give you 1 numerically, but because we got an odd number, of course, it returns you -1. So x minus 4, I'm getting rid of the seventh root, essentially from this line to this line, is equal to -1, and therefore there is only one real solution again for this equation, and the answer is of course 3, because I just add the -4 rather, to the other side. I hope you enjoyed it. I hope you followed what I've just done in there. It's quite interesting if you haven't seen this before. I'll see you very soon. Who's laughing now?